Hi, we are going to see about CPU scheduling. In the CPU scheduling, we are going to see the fourth type, that is round robin. Round robin in the sense we are going to repeat the scheduling round wise. That means there will be some time slice at the time quantum will be given. That means we are going to execute the process only for the time which is given here. After the completion of the time, the process will get stopped and goes to waiting room if it is not completed. Then the next process in the queue will be executed. After completing all other process in the list, the process which is in the waiting list waiting for the next execution will be considered and it is taken for the execution. This is known as preemptive scheduling. Preemptive scheduling in the sense we are going, once the process is being given for execution, it will complete and come out. That is known as non-preemptive. But here, even though the process is not getting completed, it has to be stopped and the next process is given. So in this situation, it is known as preemptive. FIFO, these are non-preemptive. Here, as this process gets stopped and next one is given, so it is known as preemptive scheduling. For the same example, if the time quantum given is 4, in this case we have to find our NAT chart. Here, first, similar to the previous process, P1 will be taken for execution. So there is no waiting time given in it. So it is 0. So here the time quantum given is 4 seconds. And we have to check with our burst time whether this is, which one has the less or same value. Yeah, burst time is more than our time quantum given. So after completing 4 seconds, P1 gets stopped and it goes to the waiting for all other process to get completed. Next, the P2 process is taken for execution. Here we can check, this is 4 and this is also 4. So 4 is taken. P2 gets completed at 8 seconds. Next process is P3. P3 is taken for execution and we have to check here 4, it is 5. So next time quantum of 4 seconds is given and it comes as 12. Next, the P4 is considered taken for execution and we have to check here 4 time quantum is 4, but for P4 execution it takes only 2 seconds. So in this situation only the 2 seconds is enough for allocating to P2 P4 process. So after it will get completed within 2 seconds and the overall time taken is for completion of P4 is 14 seconds. Next, P5. P5 is taken for execution and here the time required is 1 second only. So 1 is enough. So P5 will complete its process at 15 seconds. Next, we have to check whether all the process is completed or not. So P1 required 4, but here we have used only, P1 requires 8 and here 4 is allocated. So we have to P1 is still in waiting stage for completion. It has not yet completed. So again P1 comes for execution. So P1 is 8 but only 4 is completed. Again 4 is pending. So it is P4 is waiting in the waiting state for getting completed. Next, so it takes 4 seconds and get completed at 19 seconds. Next, P2 requires 4. It already completed 4. So now P2 is not in the waiting list. Next, P3 is taken. P3 required 5. 4 is completed, remaining 1. So for 1 second it's waiting in the waiting list. So next P3 is considered for 1 second and it gets completed at 20. So next P4 requires 2, so it is done, and P5 1, yeah, it is also completed. So here all the process gets completed. So this is our NAT chart. It totally differs from the other 3 scheduling types. Next we have to find our waiting time. Here this also little bit differs from the other thing. P1, P2, P3, P4 and P5 waiting time. Here the waiting time is for P1 is 0 and it does not start waiting before, so that is also 0. Then we have to check whether any other again the P1 is taken for execution. Yes, P1 has again taken, so we have to consider that waiting time minus the process P1 where it gets completed, so minus 4, so that is 11. Previous 3 things we will be taking the waiting time minus the, if any waiting time mentioned, that one. Here it totally differs because P1 comes for execution in 2 times. So first 0 and there is no waiting time, that is 0 minus 0, plus P1 is waiting until here for second execution is 15 minus where the P1 gets completed, so that is 4, that is, so the value is 11. P1 waiting time is 11. Next P2 is 4. Initially there is no waiting time, so 0. No, P2 is gets completed in first time itself, so the waiting time is 4. Next P3 starts, waiting time is 8 minus there is no previous waiting, so plus. Then P3 again comes for execution, so that is 19 minus where the P3 gets completed previously, 12, that is 7. 8 plus 7, it is 15. P4 is 12 minus 0, that's all, P4 does not come again. P5 14 minus 0, the 14. Next we have to find our average waiting time. Average waiting time means sum of these values and by the number of processes. So that is 11 plus 4 plus 15 plus 12 plus 14 divided by number of processes 5. So 15, 30, 56 by 5. So that is 1, 1, 2. So the average waiting time is 11.2. Next is our turnaround time. This will be easy as previous one, just we are going to add our burst time and waiting time. So P1, P2, P3, P4 and P5 turnaround time, waiting time plus burst time. The waiting time of these processes are 11, for P2 4, P5 15, 12 and 14. Our burst time is 8, 4, 5, 2 plus 1. So we have to find our average turnaround time. So 11 plus 8, it is 19. So this one is 8, 20, 14 and 15. So 19 plus 8 plus 20 plus 14 plus 15 divided by number of processes, that is 5. So it is 76 by 5. So the value is 5.2. So turnaround time is similar to the previous all process, but the NAT chart and waiting time differs here. This difference is because of the time quantum given for its execution. If suppose the time quantum given here is 4, instead of 4, if 8 is given, this is our maximum. This is similar to our first in first out. As it process does not get completed, it again comes from waiting stage to the execution. Here the waiting time is calculated as initial where P1 gets starts minus the initial waiting time plus second time where P1 state starts and where it gets completed. Likewise for all other process, and we are finding our waiting time, average waiting time. Next our turnaround time, that is our waiting time plus our burst time, and find our average waiting time of it. Okay, thank you.